Hi, good morning everyone. This is Jagdish, Assistant Professor of EC Department, SNS College of Technology. Today, in our AIML, that is Artificial Intelligence and Machine Learning video lecture series, we are going to discuss about the topic regression. This topic comes under the Unit 2, that is supervised learning. So, let's dive into the topic. So, what is actually a regression? So, regression analysis is a fundamental concept in the field of machine learning. It falls under supervised learning, wherein the algorithm is trained with both input features and output labels. It helps in establishing a relationship among the variables by estimating how one variable affects the other. So, regression in machine learning consists of methods that allow data scientists to predict a continuous outcome. That is, outcome is here y based on the value of one or more predictor variables, that is x. So the input is x. So linear regression is probably the most popular form of regression analysis because of its ease of use in predicting and forecasting. So let us see the one example, right? Imagine you are car shopping and have decided that gas mileage is deciding a factor in your decision to buy. If you want to predict the miles per liter of some promising rides, how would you do it? That means you will analyze with the different parameters, right? Like uh, by plotting the average MPG, that is a miles per gallon of each car given its features. You can then use the regression technique to find the relations of MPG and their input features. The regression function here could be represented as that's a dollar y, which is equal to f of x dollar, where y would be the MPG, that is a miles per gallon, and x would be the input features like the weight, displacement, horsepower, etc. So the x is nothing but of here independent variables. The independent variables, if the changes will occur in the independent variable, that will reflect in the dependent variable, that is a y, that is a miles per gallon. So the miles per gallon is the ultimate thing we have to concentrate. So for the miles per gallon, that's miles per liter, that's a mileage, depends on the various input factors, that is the independent factors, that is given over the x-axis, right? Like weight, displacement, horsepower, etc. So the target function is the output, right? That is a dollar f dollar, and this curve helps us to predict whether the car we can buy or not. This mechanism is called as a regression. So regression, finally, what is the meaning of the regression means? We have that defines the relationship between the independent and dependent variable, right? Like a graphical representation. And again, one more thing, one more example we can see. So let us say you have developed an algorithm which predicts next week's temperature. The temperature to be predicted depends on different properties such as humidity, atmospheric pressure, air temperature, and wind speed. But how accurate are your prediction? How good is your algorithm? How you are going to evaluate? That is the thing, right? So here we can evaluate by means of some metrics that we will see. So let us, before seeing the metrics, let us have the classroom activity. Right here, it is on reverse puzzle. We can check with the each block, right? So last class itself it has been shown, but many of you not have. Find out the answer. At least now you quickly find the answer. You can Google it, the thing, and you can tell the answer. You make a group. You make a group and discuss with your group members and tell the answers. And so let us resume the session. Evaluate a machine learning algorithm. We have two evaluating metrics up there. That's a variance. Another one is a bias. Okay, variance. What is variance? Variance is the amount by which the estimate of target functions changes if different training data were used. It's called a variance. This is one of the metrics to be considered when you are evaluating the machine learning regression algorithm. And the next thing is bias. So bias is the algorithm's tendency to consistently learn the wrong thing but not taking into account all the information in the data. For the model to be accurate, bias need to be low. If there are inconsistencies in the data set like missing values, less number of data tuples, or errors in the input data, the bias will be high and the predicted temperature will be go wrong. So from that you can understand the what is the bias and what is the variance. So the bias or and the variance must be low so that the prediction value will be accurate. So let us come for the assessment. So evaluate the any regression model in machine learning by suitable metrics. So this is the assessment. Thank you.